This is R.D. Sharma Solution, Class 12, Chapter 19. Exercise is a 19.11 Indefinite Integrals. So, most of the questions which we are going to deal are based on tan and sec. So, for differentiation of tan x and sec x, we know the final result. So, when we take t equals to tan x in this case, dt by dx will be equal to sec square x. That is directly available to us. Sec square dx is directly available to us. So dt will become sec square dx. So when we place t equals to tan x, integration will become like this because tan x is t. This will become t cube and sec square dx will be dt. So this t cube will be t raised 3 plus 1 divided by 3 plus 1, that is t raised 4 by 4. X raised n integration you already know. It's x raised n plus 1 divided by n plus 1 plus constant of integration. So this is the final result of integration of x raised to n, which we are going to use here and in most of the part of this exercise. Then we add the constant of integration. Now this t equals to tan x. Just write this tan x to the power 4 divided by 4, that is 1 by 4 also you can multiply, and plus constant of integration. That's your final result. So this is the reference for you. It's a very straightforward question because no assumption has been taken except t equals to tan x. Now in this question, sec x tan x, if you differentiate sec x, tan x you already have seen sec square x. So this sec raised 4x. This tan x I am writing like this. Sec raised 4x I am writing as sec square x and sec square x. In this 1 sec square x will be converted to sec square x will be 1 plus tan square x. The next sec square x we will keep it like this. This dx remains here. Integration of this will become. So this t, when we take it as tan x, we have just taken this in the previous question. Dt by dx will give you sec square x. That is sec square x dx, if we put t equals to tan x, will become dt. This integration will become like this. Tan x, of course, t, 1 plus tan square, that is 1 plus t square. Sec square x dx is dt. When you multiply this inside, it will be t into 1, that is t into t square will be t cube. When we integrate this, let us separate these two terms, t dt and t cube dt. T will be t square by 2. T cube will be t raised 3 plus 1 divided by 3 plus 1, that is t raised 4 by 4 plus constant of integration. And what was t? Initially we have taken it as tan x. Now replace this as tan x square divided by 2, tan x to the power 4 by 4 plus constant of integration. That's your final result. So this is how we are going to go about it. And the main thing is, if you are convinced enough that we can change this sec raised 4x into sec square x into sec square x, then it's easier for you. Now again, this question also has no other thing except what we have done in the previous two questions. If we place t equals to tan x, dt by dx is sec square x. So dt will become sec square x dx. So we need to separate these two terms. The sec raised 4x divided into two terms. So tan raised 5x. Sec 4x is sec square x into sec square x, and we have this sec square x as 1 plus tan square x. Now all the left terms are all tan terms, and sec square x dx we already know. This we can write it as dt. So I am writing now this tan raised 5x as t raised 5. 1 plus tan square x is 1 plus t square. Sec square x dx as dt. This will be t raised 5 separate term. T raised 5 into t square, that is t raised 7 as the separate term with a dt. Now this will be t raised 5 plus 1, and this becomes t raised 7 plus 1 to 8 by 8. So 1 by 6, t will be tan x to the power 6 plus 1 by 8. This becomes tan x to the power 8 plus constant of integration. So this is the result I was talking about, and this is the reference you can use in order to solve it by yourself, because I encourage you always to do the things by yourself. Only when you have problem, then refer the solution. Now here the things have changed. Now you need sec x tan x, and for that you need sec x, because when you take t equals to sec x, the differentiation will become sec x tan x. So we'll separate these accordingly. So t equals to sec x, dt by dx will be equal to sec x tan x. So this dt will become sec x tan x, and dx is already there. One sec can be combined with tan x in order to get this dt. So the sec power remains is sec raise 5x. This sec raise 5x, how are we going to write it? Because it's t. So t to the power 5, simply t equal to sec x. So this integration will become like this. T to the power 5, the rest term is all dt. Sec x tan x dx is dt. So write dt here. T raise 5 will become t raise 5 plus 1 divided by 5 plus 1. That is the standard result of integration of x to the power n. So t raise 6 by 6 plus constant of integration. So this becomes sec raise 6. 1 by 6 is already there plus constant of integration. And that's your final result. So this is the result. Just take t equals to sec x. All other things will fall in line. Now this question is somewhat different because we don't have a sec x here. So we have to do something in order to get something out of this 10 raised 5x that is easily integrable. We will write this 10 raised 5x as 10 raised 4x into 10x. Now you know the relationship between sec x and tan x. Sec square theta is equal to 1 plus tan square theta. So tan square x is sec square x minus 1. So we can use this now. This is sec square x minus 1 whole square. 10 raised 4x, it's 10 square x into 10 square x. That is 10 square x to the power square. 10 square x is sec square x minus 1. So sec square x minus 1 whole square we are going to write. Now this 10x, let it be here. Let me open this sec square x minus 1 whole square. Please remember integration and dx will always remain there. A minus b whole square, so a square plus b square minus 2ab. So sec 4x, that is sec square square, plus 1 minus 2 sec square x. So we will multiply it with 10x. So sec 4x into 10x, first multiplication. Then the second multiplication, which is plus 10x. Third will be 2 sec square x 10x. So three things have become three terms actually. So we can combine the first and the third term because we have 10x as a direct integration result of it. We already has it our hand. So we call it as I1, which is the first and the third term I am taking because they can be integrated in a way we have done the previous 4 questions. So first one will be sec raise 4x. 10x. 10 square x is sec square x minus 1. I'll just do it, but let me just add the third term first. And let me tell you that the middle term, which is 10x, was taken or will be taken as I2. Now my I2 taking it here because this 10x has a direct integration as minus log cos x or log sec x with a modulus sign in between the sec. And final result will be, we will add I1 and I2. Sec 4x, we will write it as sec square x into sec square x. 1 sec square x, we can write it as 1 plus tan square x. So this sec raise 4x will be sec square x into sec square x. One will be sec square x, other will be 1 plus tan square x. And then tan x remains the same, the last one. The first term we have tried to make it the way we can easily integrate it. In the second term also, we can just take tan x as t. So first and second term of the I1, t equals to 10x, dt will be equal to sec square x dx. And we see that this I1, both the terms have sec square x dx already in it. So integration of this term with the second term minus 2 sec square x 10x dx. So when we put this t equals to 10x, this will be 1 plus t square, 10x will be t, sec square x dx will be dt. So integration of 1 plus t square into t dt minus 2 sec square x tan x dx. Tan x is t, sec square x into dx will be t dt. Now it's kind of a, an expression which have 3 terms. T into 1 plus t square will give you integration of t and integration of t cube. This will give you 2 into integration of t. T square by 2 by t raised 4 by 4 minus 2 t square by 2. Now this t square by 2 minus t square, what are you going to get? The first and third term I'm talking about. It's half minus 1. T square by 2 minus t square is negative half. Negative t square by 2. T raised 4 by 4 is the middle term. The first and the last time I'm talking about. T square by 2 minus t square, I am saying it as negative half t square. So t raised 4 by 4, I am taking it as the first term. The first and third term gave us negative t square by 2. Now we have this integration of 10x, which is directly minus log cos x or plus log sec x. Integration of 10x, you can assume it to be like this, sin x by cos x. You can take cos as t cos x equals to t, you will get minus sin x as dt. So this cos x which is in the denominator, the log cos x will be formed with a negative outside. If you take the negative inside, it will be log sec x. I'm just trying to remind you that how this log sec x has come. So 10 raised 4x minus divided by 4, 10 square x divided by 2 plus log sec x. That's your final result. So either you can write it as, I'm trying to show you that it can be written as negative log cos x or plus log sec x. So that's up to you in whichever way you want to write. But this is the way this question is supposed to be completed. So this is how this question can be proceeded. But there is only one thing, that is I have not shown the log sec x or log cos x. 10 raised 5x can be divided in terms of 10 and sec into I1 and I2, or you can also say I1, I2 and I3. The two terms which I took in I1, you can have it in two terms, I1, I2, I3. It's up to you the way you want to do it. But you know the procedure now. So log sec x or log cos x, just include it. It will be the fulfillment of this question solution. This we are going to take in the next discussion. Till then, thank you so much and have a good one.